Hello, welcome to the STS-39 post-flight press conference. I would like to introduce the commander, Michael L. Coates, and turn the program over to him. Go ahead, Mike.
Thank you, Barbara. It gives me a great deal of pleasure to introduce the rest of my crew. To my right is my pilot, Blaine Herman. To his right is Mission Specialist Al McMonagle. Next up is Rick Heeb, Greg Harbaugh, Guy Bluford, and Lacey Beach. We were extremely proud of this flight. We feel like we accomplished all the major objectives on the flight, and we're proud not only of the job the crew did up there, working very hard for 8 days, but the people on the ground. We think we had an outstanding team put together, and I think that all the training and hard work that had gone into the pre-flight planning and training paid off when we got up there. With the few minor problems we had, they were overcome quite easily, I think, and we felt like we were part of a well-oiled machine, and we'd like to extend our congratulations and appreciation to the people that worked so hard to pull off this flight. We have a movie that we put together of some of the more interesting aspects of the flight that we think will describe the major highlights of the flight. And if we could go ahead and roll the movie. After the movie, we have some slides. We took some pretty interesting pictures, we think, on this flight, and we're anxious to show you some of the better shots. And here we are coming out of the ONC building. Even though we were the tallest crew ever to fly in space, averaging over 6 feet in height, we still look like 7 orange billiard balls walking out there.
And even though it was a pretty much standard morning, I think you'll see in this shot of the launch, we had some unique combination of environmental conditions give us a shock wave from the, you can see the condensation from the SRBs igniting right here, right behind the stack. It's quite impressive. I think that's one of the only times I've ever seen that. Of course, we lift off the pad, and the whole ascent was totally nominal, which I was happy to see, because it meant the last 12 months of training were pretty much wasted. Here we go into the we're going a 140-degree roll, heading down range, and for about the first 2 minutes we're all just pretty much along for the ride as we ride the solids. Interesting view here, the shock powering coming off the tank. Pretty clear view of the kinescope tracking us. And about 2 minutes of ascent, we get ready to separate from the solid rockets. And that, of course, all went nominal as well. And then from that point on to MECO, we are riding the 3 main engines, and just a real nice smooth ride, gradually increasing the G up to 3 Gs at the time of main engine cutoff. A beautiful day in Florida, beautiful day to be flying up into space. Nice early morning launch.
Once we got on orbit and we got to go from the control center, Lacey and I went to work opening the payload bay doors. The payload bay was very clean. It was a real testament to the folks at the Cape who do that sort of work. The footage you're seeing here is actually sped up about 4-to-1 ratio, so the doors open about a quarter the speed normally. But all that went just fine, and it was great to see the real hardware out there that we trained so hard in preparation for operating, and we were ready to go to work.
Shortly after getting the doors open, the blue shift started getting ready for bed on their first day. And we got the arm out and scanned along the payload bay here from the elbow camera in the aft. You can see AFP 675. Here we now come to the SPAS carrier spacecraft. And then as we pan the camera forward in the payload bay, which is kind of to the left from the elbow camera view, you can see STP-1 Space Test Program payload that carried a number of different gas canisters. At the top of this screen, it's a little bit dark. You can see the various CRO gas release canisters which were later in the mission deployed, ejected out of those cans, and now we're scanning forward to the cockpit area, the forward bulkhead, and then you can see the overhead windows. We're trying to wave for the camera, but unsuccessfully.
We started collecting science data with 675 just a few hours after getting on orbit. That was a shot of me in the cabin, and I'm running the Cirrus infrared telescope through its paces here, getting a little bit of a feel for how the gimbals worked. not taking science data right here. In the foreground, you can see URA with the logo and the American flag on it, the Uniformly Redundant Array, the X-ray telescope that we carried on the 675 pallet. And back in the right side out of view is the far UV.
This is a shot from the Sirius telescope, the low-level light telescope showing the aurora off the South Pole. We got some very spectacular shots of the aurora, and you can see that there in this shot here. Off on the left, you can see a little air glow. This is another shot, once again, of the aurora, and it's sort of like a dancing curtain of lights, very green lights, glowing lights as we fly through it, and if you, on some of the film, it gets a little reddish at the top. And in this shot, you can see the air glow about 90 kilometers above the Earth, and we did an awful lot of study of that.
In addition to using the cameras available to us on the payload bay, we used, or on the payloads, we also used the orbiter's low light level TV in the payload bay to take some pretty magnificent shots of the Earth. What you're seeing here are the bright splotches in the top of the picture are the Kuwaiti oil fields, which are burning at this time. And you can compare that to some of the clouds in the lower left where we had some lightning that we were able to see from space. You can see that the oil fires were burning very brightly. This is another aspect looking northwest up the Persian Gulf at the Kuwaiti oil fires with Saudi Arabia in the lower left and Iran in the lower right. At the end of Blue Flight Day 4, Blue Shift Flight Day 4, it was time to get ready to deploy the IBSS spacecraft. We'd completed the Sirius observations for the most part, and here I am grappling the spacecraft and unberthing it. I maneuvered the IBSS to its release position and handed over from there to Rick, who actually executed the release. The unberthing process was very straightforward.
The release was extremely smooth, as all of them have been with the RMS. There was no tip-off at all that we could detect imparted to the spacecraft, and it sat there just as steady as could be for several minutes until the set maneuver could be performed. After releasing it, well, here's us inside the cockpit. You can see that we had every camera available and every crewman available.
And just after the release, we wanted to test out the attitude control system of the spacecraft, so I commanded it through a maneuver that took about a minute. That was slightly faster there.
There's the separation maneuver. We tried to get a 2.2 foot per second separation velocity, and we speeded that up about 4 times, so it looks like we engaged warp right there, but it was much smoother than that.
It's a real pretty shot with the moon in the background. Here you can see the spas looking back at the Earth. You see the Earth background as we did the set maneuver and more or less flew over the spas on our way back to the far field position. The plume operation came next, and Guy has the camera scanning around the cockpit. We had every available crewman with a job to do, and you pretty much had to stay in your spot, as we talked about before the flight, in order to do your job. We had really, each person had at least one job, and sometimes folks had 2 jobs, and the communications were interesting as we called back and forth across the cockpit to pass data one way and the other. And it was really interesting to watch this whole thing in progress.
Once we got to the far field, Rick and Greg pointed the spas back to the orbiter, and the bright spot you see there on those flashes are the actual orbiter executing some RCS burns. And just another point with the cabin to show you how crowded and how busy we all were in these particular events. This is the ohms burn that one of our major objectives with the IBSS, and that flash was the ohms lighting off, and you can see the lightly shaded portion is the continuous plume for 20 seconds. At the end of 20 seconds, the ohms will automatically shut off, and you'll see sort of a spurting effect as they do, and then following that you'll see a bright flash, which we think is the purge, the nitrogen purge, which expels all the remaining propellants out the lines through the nozzles.
After completing the ohms burn, first plume burn, we did what we call the Malarkey milkshake maneuver, named after John Malarkey, who came up with these procedures. Within 5 minutes, we had to swap ends on the orbiter here, shown 6 times real speed.
where we pointed back in the direction from which we came and got set up for another Ohms burn to take us back to the previous position and get set up for another series of Ohms plumes. This is what it looked like at the near field. You can see the RCS jets firing here. In this case, you'll see 4 jets fire at once. And then the Ohms burn from the near field didn't show up quite as clearly as the far field.
There goes the first of the 3 chemical release observation sub-satellites. We didn't deploy them this quickly in flight. The first one was at about 3.5 days, and the third was at about a day later. In a second, you'll see the Crow-B observation looking at one of the rocket propellants in the canister. It was a pretty spectacular view. We're sorry we don't have color film of this. We could see this very clearly on our monitors in the cockpit as the gas cloud expanded very brightly, and then, as you'll see here, continues to expand and then begin to fade. And then in the middle of the cloud, you'll see the canister, the now empty canister, reappear, that little dot. And in a second, you'll see its beacon flash. It had a beacon to help us find it.
It's a star moving in from the bottom.
Yeah, that's right. That's a star coming up over the field of view there below.
The CIV gas release occurred also at the near field, and this is one of the gases. We released 4 different gases from within the payload bay. That was nitrous oxide, the only one of the 4 we could see.
The rendezvous itself took an awful lot of crew coordination, with 7 of us up there executing the rendezvous as well as the co-observation at the same time. It took a lot of crew coordination, and it was really a lot of fun to see it all come together and work in the orbiter like it did in the simulator.
Mike got the SPA spacecraft stabilized just out next to the orbiter, and it was an easy task to reach over with the RMS and make the grapple here. And once we had it grappled again, we did another one of our interesting handovers, and I passed the controls back to Greg.
What you're seeing here is one of the experiments we did with the IBSS later on in the mission. This is the out of field of view rejection, where we simultaneously maneuver the orbiter and the IBSS using the arm to approach and then back away from the sun. And what we're looking at is the sensor response as it approaches and moves away from the sun. This is actually 4-to-1 speed, so you're actually seeing it happen much more quickly. It's a good example of the operational complexity that was designed into this mission, and how we used every facet of both the arm and the orbiter.
Early in the mission, we knew we had a problem with one of the sets of tape recorders on the AFP 675 payload, so Blaine and I performed an in-flight maintenance procedure that was extremely well developed by the ground. We executed a procedure by which we spliced into a couple of wires to be able to send the data to the ground instead of record it on board. The guy had to make sure that the AFP 675 was safe and powered down before we went in there with all these wires. And it's not a great feeling to cut into a wire and you're not sure, totally sure the results. But we were glad to hear a few days later that they were getting great data, and it helped make that part of the mission stay alive and continue working. We went in a wiring frenzy here, and Rick will tell you about what. After that, we got him all wired up.
Yeah, during the mission, one of the things we participated in were a lot of medical tests, because as we move into longer and longer missions, we're concerned not only about how the body adapts to the space environment, but how it readapts when you come back home. And we participated as a crew in 25 different medical tests, and as you can see, they're unwired for sound.
Here, Lacey and I are changing out the lithium hydroxide canisters in our warp drive unit, our air cleaning unit, which purifies the air for us to breathe in, and involved removing the treadmill, and just basically we had a big storage volume full of these canisters. We change them out twice a day. Just part of our normal housekeeping activities on orbit.
One of the many things that aren't advertised as things that we do to stay busy.
We didn't have a whole lot of air-to-ground time to show the crew in the cabin. At one point they called up and said, "Oh, we've got a few minutes where we don't have to look at the payload. Can you show us something?" So I decided I'd give her a demonstration on how to prepare food, and I think it was Kathy that said, "Why don't you make a peanut butter sandwich?" And I had to laugh, because that's the one thing I cannot stand to eat is peanut butter. But I broke out a tortilla and made a peanut butter and jelly sandwich. Fortunately, Blaine will eat anything and everything. So after I put it together and so forth. I floated it to Blaine, and he ate it right there while I was on TV, and that's as close I've ever come to being sick on orbit, is watching him eat a peanut butter and jelly sandwich.
You need a little more jelly, boss.
A little more jelly next time. But I talked to a lot of schools, and the children love to learn how you eat in space and prepare food and so forth. And that galley is just fantastic. It's such a quantum leap from the early flights. My first flight where we didn't have a galley and we had a metal food warmer. The galley is just fantastic.
Along those, let's see.
Well, because of, this is a shot of Rick shampooing his hair during an ohms burn. And we, on our flight, did 16 ohms burns, and you can see the effect it had in the cockpit, throwing everything either one direction or another.
We also did some informal science experiments on board. You can see here is a bubble of lemonade and a bubble of strawberry drink, and the surface tension has the two bubbles bounce off of each other without combining in our first attempt to try to make them combine.
Mike, perhaps unknowingly, had laid down the gauntlet there because he had said that they had tried to do this on a previous mission unsuccessfully. So, of course, we had to demonstrate that it could be done, and that's the first known lemon berry juice in flight.
And I would strongly recommend that you not drink that stuff at home.
Well, as Greg put it, everybody's got to have a way to unwind. And it was a tight fit, but it was kind of interesting to see how you spin about an axis, and I turned out to be a pretty good subject for spinning. Maybe I'm just tall enough to fit in there. Don popped his head out of his sleep station there to see what all the racket was. I think he just gave up in disgust and closed his door.
I thought it was a bad dream.
On orbit, Don and I were scheduled for some other medical tests involving running, and I couldn't figure out why I was sweating so much, but I guess there's this metal object and all these straps attached to my feet here, but he seems to be having a lot easier time of it than I was, and fortunately, after 5 days, I broke the treadmill, and we couldn't do any more of that.
We appreciated that. We're strapped in for entry. I'm about to put my helmet on. The entry was fascinating for me because we came right down the center of the United States over the heartland of America on a pretty clear day. And going Mach 20 at 200,000 feet is a fantastic feeling. We could see the cities and airports and so forth just whizzing right by. We passed up an airliner. I wanted to wave and so forth, and it was really quite a feeling coming in for entry. I think everybody was ready to come home after 8 days of working hard up there, and when they said we're going to Florida instead of California, the crew said, okay, whatever it takes. We did a braking test as planned, except for a max brake pulse at 70 knots, and I was surprised it slows down very quickly at 10 foot per second squared deceleration rate.
I guess so much runway left, you could have done a touch and go.
Well, I considered touch and go, but we didn't waste any runway.
No, we didn't touch it.
Here's a shot of the crew coming out of the orbiter. I think we caught KSC by surprise on this landing, and it took them about an hour to get us out. And as we come down the stairs here, we're sort of trying to get our land legs under us as we descend back and make the adjustment back to 1G. At the bottom of the stairs, we had a welcome from the management. General McCartney was there, as well as Bob Seek, and welcoming us back, and we sort of expressed our appreciation for being back. And this is a shot of the crew after completing 199 hours in space, 134 orbits, and a little over 3 million miles of travel.
Now, General McCartney, before we left, said, don't hesitate to bring it back. So we took him up on his offer. We were excited about some of the pictures we took while we were up there. Of course, a high inclination flight is something most people want very much in the astronaut office, and that's one of the reasons I'd asked for this flight. And I certainly wasn't disappointed. Having the so much more of the world to look at than you do on a low inclination flight. Made the daylight passes fascinating. In this case, because of all the aurora activity at the South Pole, even the nighttime passes were fascinating. It seemed like we were taking pictures all the time, whether it was in daylight or darkness out there. We've got a series of slides we'd like to go ahead and show you and talk to you right here. If we could...
Here's a picture of just before the SPA's retrieve. Mike's got the spacecraft stabilized, and you can see the sun glint off of the water there, and the arm is poised just ready to make the grapple. The SPA spacecraft you can see a little bit of here. The large sort of barrel-looking thing on the right is the infrared telescope housed inside of a cryostat, and that was the primary instrument on the spacecraft. The Arizona imaging spectrometer is also on the spacecraft, but you can't see it in this picture. It's around on the other side. The spacecraft as a whole performed beautifully during the mission. Everything was very much as expected. It behaved very well.
Guy and I shared this corner of the flight deck to conduct all of our 675 operations. The green monitor, the keyboard just to its right, and the switches there are the command and monitor panel that we use to control all the AFP 675 experiments out in the bay. And just to the right of that, with some amber-colored numbers on the display, is one of the small portable computers that we carry on board. And you can see over my left shoulder the hand controller, one of the hand controllers for the RMS, and the white glowing monitor is one of the orbiter's closed-circuit TV monitors.
This is one example of the sort of visually spectacular images that we were able to record, although photography never does them justice. This is the CIV release, the NO again. You saw that a little bit earlier in the film. It was the one that was most spectacular. In fact, of the 4 gases that were released, the xenon, neon, and CO2 were the other 3. This is the only one that we could see, and we saw it on 2 different occasions during night passes. We also released this gas, the series of gases during the daytime, and were not able to record anything visually, but you should have been there to see this. It was really something.
This is a picture of the glow. You can see on the right part of the orbiter, as we look at this picture, the orange glow that resides behind the orbiter for a few seconds after the orbital maneuvering engine firing quits. And at the same time, you can see the thrusters, the upward and, in this case, left firing thruster that fired to maintain attitude control after the Ohms burn. Seeing these thrusters firing, capturing them on film were quite spectacular.
All of us tried very hard to get pictures of our hometowns during the flight, and there's my hometown, Riverside, California. You'll probably recognize Los Angeles in that shot too, but my hometown's down there at the bottom. We never did get North Dakota or Michigan in there, did we? It was always covered by cloud.
But we did get Cleveland.
We got Cleveland, yeah.
Well, New York's not my hometown, but we were rated up from the ground. They wanted they had some good opportunities to take pictures of New York City, and so we gathered our cameras together. This is a really unique color IR picture of New York City and the surrounding suburbs. All the red you see is basically vegetation. All the gray is urban development. And the detail on this is just outstanding. You can get down to actually seeing Central Park. You can see bridges, ships in the waterway. You can see different airports. You can see the Yankees are playing an afternoon game, and it's just really good detail from 140 miles out with the 250 millimeter lens.
Is that Don Mattingly up to bat?
I can't read the number. Can I have your glasses? Do we?
Here's a shot of San Francisco and the Bay Area. Lacey and I spent an awful lot of time out in this part of the country training for 675. I don't think we spent much time in San Francisco, but this is a good shot of San Francisco, and across the bay you can see Oakland, and just outside of the picture is San Jose, and Sunnyvale is where we trained, and you see where the Golden Gate Bridge is, just left of center, and the Bay Bridge.
We also got a pretty good overhead shot of the Dallas-Fort Worth area. You can see the heart of Dallas there in the central right part of the picture, and the heart of Fort Worth on the left. And between the two and slightly above is you can make out all the runways of the Dallas-Fort Worth airport. You can make out Carswell Air Force Base on the far left side, and Dallas Love Field just north of the heart of Dallas, and several of the lakes around Lake Worth and Lake Dallas. It was a spectacular shot.
As we're coming across the middle of the U.S., Blaine and I both had cameras out, and we were taking pictures of major cities one after the other. 40 seconds after we got the picture of Dallas-Fort Worth, we got this picture of Houston. And you can clearly see Galveston Bay and, of course, all the city and the airports. And I've made a valiant effort to try and get a picture of Jamestown, North Dakota, where I grew up. But since I couldn't get Jamestown, I decided to, since Houston's more or less my hometown now, that I would claim Houston as my hometown for this flight anyway. And there are some, again, I guess because of our low altitude and the quality of the cameras, when you look at these pictures with a little magnifying glass, you can see the streets in our neighborhoods, and everything comes out very clearly.
That's my Little League team that's up to bat there.
They win or lose that one.
I'm not saying.
He wasn't there, so they won.
It's not my fault.
Oh, that's
That's
me.
you.
Sorry about that. Okay. I was sitting here trying to figure out who was supposed to talk here. This is a shot of Kamchatka Peninsula in the Soviet Union. In the lower right-hand corner, I know it's pretty difficult to see, there is a volcano erupting. And we caught this shot on the first day of our flight, and you might see a little bit of smoke trailing from the upper portion of that volcano going to the right of the slide. Next slide. This is another shot of the same volcano as in the upper center portion of the slide, and you can see that the eruption has stopped, and you can see the soot on the southern edge of the volcano. Rather spectacular shot. This is a shot of Colima, an active volcano just south of Guadalajara, and you can see it's actively erupting, and you can see the smoke plume associated with that eruption.
Because of the 50-70 degree inclination, we spend a lot of time in the northern and southern extremes of the world, with looking over Siberia and Kamchatka and Canada and catching just the edge of Greenland. One of the things that we saw several times was this scene of sea ice. It looks a lot like clouds, but in fact that's ice floating in the North Atlantic Ocean, and you can see that it's fairly straightforward to try and look at that and see that there's an awful lot of activity ocean current wise and wind effect on the sea ice as it moves it around, and makes a really interesting picture.
That circular feature in the middle of the frame there is Gora Kandar, which is located in the extreme eastern USSR, about 300 or 400 miles inland from the Sea of Okhotsk and about 850 or 900 miles north of Vladivostok. Although it hasn't been confirmed as such, it has many characteristics that would suggest that it is a meteorite impact crater, about 5 miles in diameter.
This is a nice oblique perspective of the St. Lawrence Seaway, looking southwest in the upper, well, just to the right of center in the picture is Quebec, and just as the seaway disappears under the clouds, up to the right there is Montreal. I wanted to point out that Montreal is one of the locations where some work is done on the shuttle arm by the Canadians, and as we demonstrated on this flight, the arm performed extremely well, so we're happy to take a picture of that part of the country for those folks.
When the sun reaches certain angles, you get a really unique perspective of looking at the water and the oceans, and you can tell certain subsurface currents and boundary layers and things like that by picking the right times of sun glint. This particular picture captured the ocean currents just off the coast of Cape Hatteras, North Carolina. And the bright areas you see indicate smooth water, and all the rest of the photo of the water, you can actually see the currents and the eddies and so forth that exist out there just off the coast. The little triangular tip of land to the left of center is Cape Hatteras, and the dark area, fairly well delineated on the right side of the photo, represents the Gulf Stream. So you can see quite graphically the effect of the Gulf Stream running up and down north-south along the coast, eastern coast of the United States. And this one here is the Straits of Gibraltar and a bleak view of it, but it was amazingly clear most of the time we came over the Mediterranean. We were just, there was always quite a bit to see down there in terms of currents and spillovers as the water passes through the straits, but this was one of the more dramatic shots we got that shows both the European continent and the African continent.
I had a particular interest in the Kuwaiti area since I have a brother that's stationed over there along the Persian Gulf in Saudi Arabia. And I'm afraid on this day, because the oil fires were burning quite violently and still continuing to burn quite violently around Kuwait City, and the winds were northwesterly, that the black clouds of smoke coming off the Kuwaiti oil fields were going right down the Persian Gulf. And I'm sure that my brother was seeing the black cloud palls overhead. These cloud palls continued all the way down the Persian Gulf and through the Straits of Hormuz all the way to the end of the Saudi Peninsula. If you look to the upper right in that photo, we transition to this photo here. This is taken in color infrared as opposed to the last one taken in color visible. You can see the bright areas in the water to the right of this slide, which are oil slicks that show up very well in color infrared film. Oil slicks which are the residue left from the dumping of oil that was done from the Kuwaiti ports into the Persian Gulf. And here's one more perspective. This is, at the bottom of the screen is the United Arab Emirates, and the black along the coastline there is oil resulting from the spill. You can see it extends for a significant distance.
The CIRRUS instrument, the cryogenically cooled IR telescope on the 675 pallet, one of its primary objectives was to observe the aurora with their IR sensors, and we were fortunate to have a large storm on the surface of the sun during the mission, which resulted in some very spectacular aurora over the southern pole of our planet. The colors that you see here are captured by 1600 ASA film, 35 millimeter 1600 ASA speed film. To the naked eye, we could see whitish and greenish colors very clearly and tinges of red. It doesn't show up well on the monitor here, but I think you can see a reddish fringe extending upwards from the brightest part of the aurora there to, we estimate, an altitude of around 300 or 400 kilometers to above our orbital altitude. That very bright light at the top of the picture is the moon. Here we have a really spectacular view of moonlight on the water and fire in the sky over the southern pole of our planet. If we could stand off from the Earth a few 100,000 miles, and if our eyes could see the Earth's magnetic field, the Earth would look like a giant comet trailing a long tail of magnetic field lines behind it, just like a comet appears in the sky. And as particles are expelled from the sun, they're trapped in that magnetic field and then accelerated like a gigantic atom smasher into the Earth's atmosphere. And we'd be able to see the glow on both the north and south poles as those electrons come smashing down into the atmosphere and collide with the molecules there and cause this glow. As you look at it, just at the level of perception, you can see the aurora move. It moves with a sort of a stately grace, and sometimes it's almost that you don't really see it move, but it appears to change. You suddenly realize that things have moved, and these long spires of light move gracefully across the sky. And when you look closely, there's an inner dance within that larger dance, as very active things seem to go on. Again, just at the level of perception. Inside those rays of light, you see faster activity. And of course, the scientific instruments that we were carrying were focused on the inner dance within that dance, the actual movement, the energetic dance of the molecules and atoms at the quantum level, obeying the laws of physics.
Boy, for a pilot, you're pretty eloquent. I think we found somebody to write the crew report.
Bob wrote that for me. This is one of the better conditions, but also a poor example because you can't capture on a photograph what it looks like of one of the 16 sunsets that we saw every day. Just for your information, this particular image was digitized, and just in the blue layer of the sunset there, the analysts have identified 16 different layers that they think are different dust level layers in the atmosphere. Again, seeing a photograph of it just does not do it justice. The sunsets and sunrises were so fantastic that the blueness almost seemed to glow as the sun would come up or set.
Well, we were also the first crew to fly 7 astronauts from the astronaut office, and a lot of people questioned whether they'd ever be able to pull this crew together, and I want you to know, at least for one brief moment, all 7 of us were together up there. We saved this photograph for last. I think it's one of the most spectacular photographs we've ever taken from space. We're always trying to capture the RCS thrusters or the OMS engines firing, and we're always trying to get the glow on the side of the orbiter. And of course, in this photo we have both of those. You can see the glow on the side of the vertical tail, and you can see the RCS thrusters firing. And in the background, you've got the aurora down there with an awful lot of color. I don't know if you can see it on the monitors, but there's a lot of red in that aurora at the higher altitudes. And of course, you've got the stars in the background, and I think that's just a spectacular photograph. And according to Photolab people, all 7 of us have individually claimed we took that shot. That's the STS-39 photo, I think.
This discovery for income, it's kind of a funny thing here. We've discovered that camera Charlie, when we feed it to VTR2, we get a no video light. When we feed it to VTR1, the video light stays off as it should. And we haven't had a chance yet to check and see whether or not we're really recording anything, but for right now we're recording on VTR1.
Okay, we copy that, Rick.
But other cameras feed okay to VTR2.
Okay, we got that. Hey, Lacey, we're looking at the aurora. It looks great.
Looks fantastic.
Discovery for Lacey CIC. Dick Nadilli says that's a landmark measurement. You're right on target. And congratulations.
There's so much out here, I don't know what to point at. Congratulations to all you guys that built this thing.
Doing a fine job. We're elated. Dick says he's so excited he could stay up another 12 hours.
Jeff, as you're looking at the picture there, you see the whole Earth to the right, and then there's kind of a distinct white line. That's the air glow layer, and it's about 90 kilometers up, and then the aurora is scattered around above and below that. Generally, I think most of the aurora is at more or less of a constant altitude around the Earth, and we're kind of seeing through the Earth limb, so we see the aurora at different, kind of appears to be at different heights, but it's not quite as, it's kind of hard to explain that, I guess. The bottom of the aurora, it doesn't move up and down as much as it appears to. The sheets are real.
Okay, we're still looking, and this is still camera Bravo?
Yes, I think so. If it isn't color, it must be. At this point, I remember we were looking pretty much straight along the velocity vector because there's Orion setting. CIC Discovery.
CIC Discovery, go ahead.
Yeah, Roscoe, in the event that we don't get discrete aurora for some of these modes, what gimbal angle would you like us to use?
Okay, we want you to
Gimbal roll angle.
gimbal roll to negative 20 degrees, negative 20.
Okay. This is a pretty interesting experiment. Basically, it's an X-ray imager. It's called the URA, the Uniformly Redundant Array, and it uses a coated aperture to collect X-rays. We've been looking today. We finally got a way to get data collected. The data goes on to the ESS tape recorders that we've been having problems with. So with the IFM that we did earlier today, we're going to be able to collect actual science data for URA. We're all really happy about that. The instrument itself, if you want to take a quick look out in the bay, maybe we can do that. Let me see if I can get the camera up. We'll try and get the camera D up and take a look out at the bay at what we're working with. The URA is hard mounted to the ESS pallet. It points out along our right wing. So we maneuver the orbiter in order to point the instrument at an X-ray source. Now earlier today when we started out, we did one data pass looking at the galactic center, which is about 30,000 light years away from us. So the light coming from there has been traveling through space for 30,000 years. Later today, we're going to, after that, we think we took a look at an X-ray source. Okay, we're getting the payload bay picture up now. And we'll put that over on the downlink for you for a minute here. You can see the business end of the URA right to the left of the IBSS doer, and you can just make out the URA emblem on the instrument. The aperture is to the left as you look at the picture, and you can see that it looks out basically aligned with the right wing. Count rates, we're basically counting X-ray photons with the instrument. It's kind of an interesting device. The front end of it is a coated aperture with some 25,000 holes drilled in sheets of stainless steel with a stack of, I think, 16 sheets. The holes in the aperture are arranged in accordance with the Fibonacci series. Ed Fenimore, the PI, says that Fibonacci series have magical properties. And that's the extent of my understanding of the mathematics involved in reducing data. In any event, the X-ray photons, which are coming in at a rate of only a few a second, pass down the barrel of the instrument, go through a mylar window and into a chamber of xenon gas, where the X-rays strike molecules of xenon and Kathy, you can explain the quantum physics that goes on here to anybody that wants to know. But they're changed into UV photons, which then pass through a calcium fluoride window, a monolithic crystal of calcium fluoride, which is transparent to ultraviolet radiation. Now, once the ultraviolet photons get into the next chamber of gas, which is filled with P20, with a trace of another gas called TAMI, something else, according to our PI, which has magical properties. Those ultraviolet photons are turned into a shower of X-rays when they strike molecules of gas in that chamber. That shower of X-rays then passes through an electronic grid, and the location of each electron is then mapped, and that data is stored in the computer, stored on the data tapes. And that's the data that's being transmitted to the ground. Now, by using Fourier transforms after the flight, in effect, Dr. Fenimore and Dr. Dupree will reverse the process, and they will track back that shower of ultraviolet photons and compute the position of the original X-ray photon as it came through the aperture of the instrument, and thereby construct an image of the object. This instrument's unique, I understand, I'm told, in that it does both imaging and also does energy as you know, packets are always, food is always distracting, Kathy. I apologize. In any event, the instrument is an imager, and it's also can also measure the energy spectra of the X-ray source. I think later on today we're going to be looking at quite a few different X-ray sources. One is known as 4UO. Have you heard enough X-ray physics for now? We don't know what he's talking about, Kathy, but we're trying to help him out all we can here. Trouble is, neither do I. If you really want to understand this, you'll need to go to talk to Ed Fenimore and Diane Dupree. Seriously, this is probably the most quietest time we've had in the flight right now, this last hour anyway. And we would like to take the opportunity to thank everybody that's worked so hard getting this flight ready to go and pulling off the flight once we got up here. I know with the problems we've had, it's been a challenge, I think, for all the experiments. Everybody's had something to think about and work on during the flight, and they've just really come through. And all the months and years of preparations that have gone into this flight have really paid off. I think Rick had a good comment a while ago. We just finished up the IBSS experiment that we've been doing for the last 6 days, and in the checklist I think he said we found maybe one mistake, one trivial error in the whole checklist, and the checklist is about that thick. So that really says a lot for all the thousands of man-hours that went into making the experiments work and the checklist work and pulling all this off. So well done, and a kudo to everybody that has worked so hard. Kathy, we're playing back for you now the Aurora. This was about where Mike was seeing it very bright out the port window. What you're seeing, you can see the orbiter port wing in the bottom part of the picture, and on the right-hand side is just barely the tip of the end effector. And so I had the camera panned over there all the way around as far as it would go to look at that side and then watch for the Aurora. Now you can see it starting to sort of snake its way closer to us, and eventually here it'll come all the way across the horizon.
I can see that, and you're right about the dark glasses. I can see it blooming the camera almost.
Yeah, it was kind of a difficult choice. If I went to white stretch, I'd get all of those, all the vertical development. But then then it blooms in the middle. But see how it's snaking toward us here? It's almost, looks almost alive. Now at this point, I switched and let the auto iris take over. So now you're seeing only the bright stuff, but you're seeing it without blooming. Over the course of the next few minutes, it just works its way all the way across the sky. Here you can see how rapidly it's moving. It's pretty dynamic.
Yeah, we can see that.
Discovery. Kathy, do you want us to go ahead and start the water dump, try to get that done before the PQ04?
Stand by, Mike.
How's that downlink look, Kathy?
Fantastic.
Yeah, we can't tell from a monitor how good it recorded.
Discovery Houston for Mike, STP-1 is active right now and will be for about the next 15 minutes. When that's complete, then we'll give you a go for the water dump.
Okay, we'll stand by on your go, and I presume you just want to stay in this attitude until we hear differently.
That's affirmative. And your video playback looks to be about as good as the live TV we saw earlier.
Okay, that's good to hear. Kathy, here I'm panning all the way across the horizon is what I'm trying to do to show the extent of this. So I started at the port wing, go around on the nose here, and now coming down the other side to the starboard wing.
This is kind of like being at the right place at the right time, isn't it?
Apparently. Well, actually, I think it was good flight planning.
Yeah, we'll concur with that.
Delta, we got another Spec 76 comm message, but nothing's out of limits on that display, so we'll let you look at that.
You can disregard that, Mike. We don't see a problem either.
Roger. KT, after this tape is complete, if you want, I can back up the tape we also made of the Cirrus low light level TV, which shows what Lacey was seeing as he was gimbaling around, if they'd like to see that.
Sure, if you have time to do that. And can you confirm for me that when you were shooting this with a 35 millimeter, you were using 1600 ASA and 2.48 seconds?
That's affirmative, Kathy, although it was awfully hard to hold the camera still because, both the orbiter and, of course, the roller were moving, so the 8-second exposures, I'm sure, are going to come out blurred.
Well, it's supposed to look a little bit fuzzy, isn't it?
Yeah, I guess that's right. Okay, KT, I'm going to switch, play back some of the stuff from the L3 TV, and I haven't really queued it up, so I'm not quite sure where it'll start out.
Okay, we're watching.
Every now and then, Lacey switches from one camera to the other. He's got a wide field of view camera that's about 28 degrees across in the horizontal direction, and a narrow field of view camera that's about 5 degrees across. Right here you're seeing the narrow field of view, and the other image you were seeing a minute ago is from the wide. Yeah, here's the wide field of view camera. So he uses that to sort of home in on the aurora, then switches to the narrow to fine-tune it.
On the narrow field of view, it looks like the reticle has settled down a little bit. Is that true?
Yeah, I think it's doing fine now. It cooled off.
Okay.
There's Lacey to tell you what he was really doing, so I don't have to guess.
Kathy, right now we're in a horizontal raster mode. The Cirrus is executing an automatic gimbal scan right now. For the fighter pilots in the crowd, it's pretty much like a 4-bar raster kind of scan, just like a air-to-air attack radar does. It's sweeping back and forth across the aurora there. My only task in this part of the exercise is to set the heights, the tangent heights at about 90 kilometers, so that we're looking out at a point 90 kilometers above the Earth at the air glow layer. Find the brightest part of the aurora by gimbling and roll, and then executing the sequence, and the rest it does automatically, scanning back and forth like you see it doing now. As you can see here, it's the aurora is starting to disappear over the horizon because it's getting fainter and fainter, so we'll just continue to scan on the place that we last saw it the brightest. And here comes some more into the field of view over on the right. Okay, I remember what happened here. With Mike and Rick and Blaine looking out the windows, they were spotting for me, and they saw some pretty bright activity off to the right. I'd been looking at some stuff over towards the left, so when it finished of it sweeping and was waiting for me to reinitiate the next segment, I scanned over to that brighter area there and set it on its way again. I even had a chance to look out the window a couple of times, and it was really spectacular.
I was hoping you weren't stuck with your head down in there all the time.
And for CIC, disregard. Meanwhile, over here on the sunny side of the planet, we're just coming across the Alaskan coast. We think we'll be shortly across the Alaskan southern panhandle and over into Canada and across the Rockies.
How's the weather? Is it clear up there?
Big system out over the water here. Clear below us right now. There's a fair amount of cloud cover. Big system out in the Gulf of Alaska right now. Unless you want more of the, it's your call whether you want to continue the playback or take RMS elbow cameras.
Stand by. How about taking the elbow camera now and bringing this videotape home for us to look at later?
Sounds like a plan. Kathy, if you want to look at the Earth, pan the camera left about 90 degrees.
We're heading that way now, thanks.
If we're lucky here, somewhere on down the road, we might get a shot of Willoughby.